this was what we would call a sustainable building. It has these features: high performance building envelope, which is what we've created. It promotes daylighting, which we'll talk about a little bit later on. High efficiency building systems, which is the smaller, very efficient boiler or other systems you may have. And minimally invasive site work. The more you work on the site, the more you have overhead, the more you have maintenance, the more cost you have. So if you can leave a certain portion of your site undisturbed, it allows stormwater to penetrate, and there's no grass cutting, and there's less maintenance on that area. Most of us have some form of fuel that we use to heat our buildings, our offices, our homes, and so forth. And if you just think about how many gallons of oil you might use or cubic feet of gas, it translates into some dollar. It's a cost. Every year, you have that same cost, except it keeps going up. The expenditure is there every year. If we had renewable material, like soy, 5 acres would equal 500 gallons of biofuel. But at what cost? The soy has to be harvested. First, it has to be fertilized and grown. Before that, it's cultivated. What equipment is being used to do that? It's tractors with probably gasoline engines. So we're expending gasoline to create a biofuel. And we do this every season so that it can go into the big boiler. On the other hand, if you had 250 square feet of properly oriented glass and right-sized thermal mass to retain that heat, it's free. And every season, when you need it, which means every winter, it's there, it's free. So passive solar design is what that represents. Capturing the sunlight, the heat from it, storing it, and allowing it to come through the building later on as it's releasing that heat into the interior space. That's free. It's either that or you're going to spend this money every single heating season for the duration of the building. And if you go with biofuel, we're talking about just reducing the amount of cost to some degree, but the energy that goes into producing those 5 acres, it's rather expensive. LEED is Leadership in Energy and Environmental Design, LEED. I'm a LEED AP, or an accredited professional by USGBC. Within our system, we have 4 levels of certification on the building. There's certified silver, gold, platinum. Every effort that goes into making that building more energy efficient or more environmentally friendly raises that by adding points to the checklist. So the more points that you gain, the higher up this scale or rating system we go. Will it cost more? Yes. On average, these are the costs associated with those levels of LEED. Now, this is not to say that it's fixed. It's not. There are architects and engineers that will work towards reducing that added cost. For instance, if you value and analyze a building's systems, mechanical systems, if you analyze the wall systems, the insulation systems, and so forth, you can achieve certain levels with really very little extra cost. For instance, in this diagram, we've reduced the size of that boiler system, which means less cost. We've taken that additional savings and put it into the insulation of the building, making it a neutral factor, almost, not quite, but what I'm getting at is that those numbers represent national averages, but they can be reduced in terms of extra cost for green. Some years ago, USGBC took a survey, and they asked clients, architects, and asked their architects to ask clients, what motivates them to go with a green building? Our children's future, 21%. Increasing energy prices, 19%. Reliance on foreign oil, 16%. Global warming, 14%. So when you look at this, we have the two biggest factors are possibly saving some money and possibly saving our children's future. If we design and build for energy conservation, we can do both things at the same time. And we can pocket the savings. Because in energy efficient building, you can actually save energy compared to a similar sized building in function. In fact, if you compare a passively built energy efficient building, you can save 75% energy over the cost of what goes into a typical building which is not built and designed that way. This is a typical scene in Manhattan. If you look at it, you can see that energy that's being expended. The cars, the lights, tall buildings, I mean, there's a lot of energy there. And as cost goes up, I think and pollution with it, I think that it becomes our responsibility as architects to design for energy conservation and the proper use of materials.
Are you saying this is a waste here?
I'm saying that it could be better. It serves a function in that it's a tourist attraction. It brings revenue to the city. It has a purpose, but at one time there was only one light blinking on Broadway, and it was a good idea. But now everything on Broadway blinks, so I don't know if it's such a good idea anymore, but there are better ways to do this.